So my name's Tom. I'm the lead developer at Device Pilot. We're a small startup. We do analytics for connected products. We're serverless all the way down. It's very exciting, but I'm not going to talk about that at all. In fact, I'm going to talk about metaprogramming in Lambda. So what is metaprogramming? Well, metaprogramming is when you write a program to write a program. Now, that sounds quite academic, but you'll use it in your workplace all the time. You've got techniques like macros, which are just subroutines that are run during compilation, which change the code before it's compiled. You've got the likes of reflection, which allow you to inspect types. You've got annotations, which are functions, which take functions and mildly change their behavior. Bytecodes, templates. There's loads of techniques underneath the disciplines of metaprogramming. Effectively, when you start treating a program like a piece of data for you to manipulate, to translate, and to create new programs from, you are doing metaprogramming. So, what's so fun about Lambda? Well, the great thing about Lambda functions is that you deploy them mostly as code. You know, if you're using a scripting language like JavaScript or Python, you have the whole source code there. Moreover, Lambda functions have full access to the Lambda AWS SDK, and that gives you all the tools you need to inspect and transform your Lambda functions. It has the APIs for you to create, read, update, and delete the code and configuration of any running Lambda function, including the function that it was called from. So let's have a look at the two main culprits. Update function code, that's fairly obvious. When you run it, it changes the code of the next invoked version of that Lambda. Second culprit, update function configuration. Now, there's something kind of interesting about Lambda, which is that there's a strong couple in the program between the code and the configuration. I guess most obviously, you've got the environmental variables. People tend to use that to set constants and set flags, which influence the behavior of the Lambda. But then you've got things like layers, which allow you to mix in new programs and new behaviors. You've got your memory size, your role, your timeout. That influences your compute and the access that you have to the account you're running in. Concurrency, event sources even. That describes how your Lambda will be invoked and the functions and the arguments it's invoked with. Ultimately, your program is not just the code, it's a configuration. And therefore, metaprogramming in Lambda isn't just about changing your code, it's about changing your own configuration. And that's it. Now you know everything. You can look at your phone, and I will whittle on for another 20 minutes. So, let me tell you a story. Let me give you an example of metaprogramming in Lambda. This is our dog. His name is Oliver. We love Oliver, and Oliver loves us almost as much as he loves squirrels. So, being a loving owner, we have put together the Squirrel Dex. The Squirrel Dex is an online compendium of all the information that we've learned on our various walks about squirrels, you know, age, sex, location, where they climb up trees. But because I'm a developer, I have put together my own JavaScript framework to deliver this application. It is called the single-lambda application framework, and it is incredibly simple. The first thing we do is we require in the data module. The data module is a hard-coded module containing all of the data about squirrels that we've learned. The second thing we require in is a database module. And that's a bit of a highfalutin term for a single function which gets from an object by ID. So if we look at our Lambda function, when it's invoked, it has a look at the event that it was invoked with, gets the ID, gets a squirrel with that matching ID, and returns that squirrel. So if we stick a UI on top of that, we can see that when we invoke the Squirrel Dex with the ID of 139, we get this apparently Welsh beauty. So, all fine, all good, all simple. Let's make life a bit more exciting for us. When the Lambda is run without an ID, what we'll say is what it actually return is the squirrel of the day. And that's fairly trivial to implement. we just give in a default ID. We'll set that to the environmental variable of SD, SOTD, squirrel dex, squirrel of the day. And at midnight every day, I will wake up and I will log into the Lambda console and I will change that variable. Nice and easy. Of course, there's probably a better way of doing that. And the solution is to make CloudWatch wake up in the middle of the night every day, give our Lambda function a kick, and we will branch our code. The Lambda function will say, hey, I've been invoked by CloudWatch, and you can tell because of the event source. And therefore, instead of just returning a squirrel, what I'm actually going to do is I'm going to reconfigure myself with this new squirrel of the day variable. And because it's reconfiguring itself, all future invocations will run with that new variable. Let's have a look at how that would work. And because this is JavaScript, we're going to work from the bottom upwards. The Lambda update function configuration, that's the API I mentioned beforehand. And what's great about that is that you only have to specify what's changing in the configuration. In this case, it's the environment. Our environment's going to say basically the same. We're just going to override with the new squirrel of the day variable. The top bit's probably the most opaque. I'm just rebuilding the environment from the environment I'm running in by filtering for the namespace SD underscore. And the reason I'm doing that is that between AWS and Linux, you get a lot of environment variables injected into your Lambda container that you don't want to be responsible for. And there we have it, stateful lambdas. In fact, this gives you up to 4 kilobytes of persistent state, which is enough for you to emulate the Atari 2600, coming soon. So now you have access to slow-moving persistent state in your Lambda. Let's muck around with code. Those of you who are paying attention might have noticed a minor flaw in this new framework, which is that after every walk, I do actually have to fire up the editor, edit the data module with everything new that we've learned about squirrels, and then redeploy the Lambda function. So let's see if we can automate that process. From the outside in, here's our squirrel dex function, the same function, we only have one. We're going to add a branch. If the function was invoked with the action key update, then we're going to fetch the ID of the squirrel we're updating and the entry of what's changed. And we're going to deploy with updated data and return the traditional HTTP response. I guess this is the metaprogramming slide. What did I say? Metaprogramming is where you inspect the data. Now, if you require in a JSON file in Node, that becomes a module that returns a JavaScript object. So that means that we've inspected that module and we've turned it into a data structure that we can work with. Namely, we can replace an ID with a new entry or add it or delete a squirrel by ID. I'm not really sure what happens when you delete a squirrel. But hey hum, once you've done that, we turn it back into code. We stringify that back into text source code, and we deploy. Now, I'd like you to hold those arguments in your head, because we're going to deploy. Hey, and this is the last slide with code on it, because I would like to continue getting jobs as a developer, and I don't want everyone to see my terrible code before they hire me. So we hit deploy, and we said we're going to override data.json with this new contents. So we're going to make our zip file. Now, the zip file is going to include all of the files from var task, which is where Lambda dumps all of your lovingly crafted source code when it sets up your Lambda container. Now, if we just made the zip file with the files in var task and redeployed it, nothing would change. It would be exactly as it was beforehand. So we're going to override the data.json or whatever file with the new contents. We're going to make that zip, and then we're going to call update function code. I should point out the zip file is a terribly named parameter, because actually it's not a file, it's just a string representation of a zip file. So this is all in memory, none of this mucking around with S3 or writing to temporary files. Hey, it's done. Once that promise is returned, the next invocation will invocate your Lambda with its modified behavior, i.e. more squirrels. And that's it. That was relatively easy. Lambdas have access to their own code, so if you want to muck around with your own Lambda's code, it's easy. You read it in, you transform, and then you redeploy. This is ideal for two things. One, it's ideal for slow-moving persistent changes in behavior, i.e. changing the number of scrolls, but it's also great if you have a data set which you need to co-locate with your Lambda. And it's surprising how many data sets you can fit into 250 megabytes. IP geo lookups come up to mind, schemas. There's a lot out there. I should probably touch on security, because it's a thing. Giving your Lambda the roles that allow it to just randomly, arbitrarily update its code and update its configuration is pretty dangerous. A solution to this is to use STS assume role. It's a good API. It makes it AWS's responsibility to authenticate and authorize your users. They then give them a token, which they take to you as a Lambda, and that allows for a single invocation, your Lambda to run with elevated permissions. I mean, it's not perfect, but it's pretty good. Lambda also has built-in versioning, so you can watch your function change with time, and it has CloudTrail integration, which means that you can get some insight into who done it. OK, so I'm not going to lie. We've revolutionized society because we've now made a serverless version of WordPress. But let's see what other fun and exciting things we can do with these tools. Self-optimization. Given that it takes about 10 lines of code to get the current configuration and redeploy with a new one, and you need 0 dependencies, it's relatively lightweight for, at the end of a Lambda invocation, you to go, well, did I meet any of my KPIs? Did I return within however many milliseconds I said I had? If I didn't, maybe I should have more memory, maybe I should have some more compute behind me. Now, you might not want to do this with Lambdas that are invoked with very stable payloads, but if you're on the receiving end of a stream and you're just pootling along with 1 or 2 records, you'd probably get away with 128 megabytes, and then when suddenly you see that you've got a batch of 500, reconfigure yourself, get the guns out, 3 gigabytes worth of RAM until that backs down again. You can take this even further, and you can start modifying your event sources, especially if you're buffering between 2 other auto-scaling services. This is actually the first time that we did any meta stuff with Lambda. One of the first things people tell you about Lambda is that Lambda functions are beautiful, and they're pure, and they're data in, and they're data out, and there's no state, and it's great. And then the next thing they tell you is that you definitely need warm Lambdas, and you need to store as much state as possible outside the scope of the function. This is great. It's a really common pattern. Connection pools, in-memory caches, parameter stores, pictures of cats. You know, you'll be surprised what people store outside the scope of their functions. The problem is that you then have caches distributed everywhere that you can't communicate with that live for an indeterminate amount of time and go stale over that time. Updating a function's configuration causes all of those warm Lambdas to be killed and forces all future invocations to work on a new initialization. And what's fun about that is that means that you can now deterministically kill transient state by having an environmental variable. We just set it to the current time, which you update every time you need to wipe the slate clean. Wow. Perhaps the most exciting and the deepest topic to look at is rapid prototyping. These days, applications are beginning to look more and more like AWS services glued together by Lambda functions. And that is fantastic for developers because it means that you can rapidly develop and you can rapidly iterate. So imagine if you had a function that took a set of instructions, and with that instructions, it recompiled a little bit of itself, or it spawned off another function to perform those instructions. With the right tooling, that means that you can give users the ability for them to express behavior, for them to express what they would like your application to do. This could be good for integrating with third-party services. It can be good for ETL queries. There's quite a lot of situations where you can use it. And although that might sound a little bit pie in the sky and unobtainable, this is exactly how most game designs work. Programmers don't make games, game designers make games, and they do it by expressing their games as data, and that is then compiled down into functions. And the great thing about AWS and the way their Lambda pricing strategy works is that who cares if your users make 200 Lambda functions that just sit around and do nothing? You don't pay for them. You only pay when they get invoked, and it allows you to deliver a huge amount of value for absolutely no cost to yourself, apart from periodically having to throw yourself on the altar of AWS support and ask for your limits to be increased. The fact is, there are tons of stuff that you can do with metaprogramming in Lambda, because by definition, if a developer can do it, a program can do it as well. So these are all of the ideas I came up with on the train on the way here, but I'm sure you can think of some of your own. So now I've given you the mallet of metaprogramming. Why shouldn't you go around treating everything else like a nail? Well, there are a few reasons. One is that it is much harder to reason about code than it is to reason about code. That is that when you see a metaprogram, you don't see the source code of what's going to run. Instead, you see the source code of the program that creates another program. And that means that when it comes to testing and security, you then need to test and secure an area of programs. And it's up to you to ensure that your program describes a valid set. That sounds quite hard, but if you are laser focused about what you are metaprogramming for, it's quite easy to control that area, and it's a solved problem. It's exactly how virtual machines work. The second challenge you might have is deployments. If you're going to persist behavior and persist state to the point that it has to persist between patches and updates to the Lambda function, the Lambda metaprogram itself, then you need to consider how you're going to maintain those changes to your function. Because remember, they're not your code. It's in the code that's now been deployed. That's another solved problem. I'm going to point you to Erlang to see how they do that. But it's doable, is what I'm saying. Cool. Update, function, code, and configuration are the two APIs that you need to metaprogram with language. Every Lambda can update its own configuration, and that means that it can make persistent changes to its state and to its behavior. Lambdas in scripting languages are especially good for this because they are deployed with their full source code, which means that you can easily inspect and manipulate that, transform, and redeploy. It's not the solution to everything. It might not even be the solution to anything, but it is good for light touches. If you have a situation where you need to have slow-moving, and by this I mean, every few minutes, slow-moving changes in state or behavior, or you want to be able to allow your users to define functionality for themselves, then this could be a good pattern for you. And as if to bring back everything on time, that's actually it. So I'm finishing early. Go forth and metaprogram.